My name is Matt Langione, and I'm a partner in the technology practice at BCG. I'm one of the leaders of our deep tech mission, which is dedicated to helping research-based technologies leap out of the lab and into the workplace. No technology, I think, today is better poised for a leap than quantum computing. And indeed, working with providers, with investors, with end users of quantum computing has become the largest share of our work. So BCG stands for Boston Consulting Group. It's a local name, but a global company with just under 100 offices in 50 countries around the world. And we bring to bear for our clients not only industry expertise, say in consumer goods and healthcare and energy, but also functional expertise, say in pricing and in operations and talent management. The deep tech mission is part, of course, of our technology practice. And it's an increasingly important one. So we've been monitoring the field for some time, but our quantum computing practice began in earnest in 2018. It's one of the fastest growing parts of the business, as I mentioned. We have 20 client projects under our belts, and we've brought more than 100 BCGers into the fold on the quantum computing topic. We've also produced some of the most widely cited reports, and we have a deep bank of more than 50 client-defined use cases that we track to monitor progress and maturity of the technology. So how do we serve clients? No, our client work focuses on really three constituents: providers, end users, and investors. And while the balance of the work thus far has primarily been with the providers who are looking for us to help them in prioritizing use cases, defining business models, building an ecosystem, as well as with investors who engage us in diligence work, we're increasingly serving potential end users. And indeed, end users are the fastest growing part of our work, which is the fact that in itself, I regard as a real bellwether of the maturity of the industry, the share of our work that's being done by end users. And that part will probably grow fastest in the years to come. So I'll focus my remarks on what we do for them. The first thing we do is typically conduct an impact of quantum assessment, or we call it an IQ assessment, to understand where there are excessive cost outlays or missed revenue opportunities in their current workflows that quantum computers can address, when quantum computers will be able to address them, and what kind of value it could create. We find that this is a great auditelic exercise because end users tend to find all sorts of things that could be improved, whether by quantum computers, whether by classical computers, or other deep technologies. Now, because this IQ assessment is the starting point for everything that follows, I'll go a bit deeper into it in a moment. But I should also note that we also help users find the right vendors and providers to partner with, to onboard talent, to incorporate quantum computing into their digital transformation roadmaps. That's a big part of the work that we do. Let me take you through a bit of this impact of quantum diagnostic. It really consists of three core analyses. First, a deep dive into pain points across the workflow and the value associated with solving those problems. Then we map those problems to potentially quantum advantage solutions. And then finally, the synthesis of that is a path to value assessment that enables users to make an ROI-informed decision about where to invest and when. Again, as I mentioned, we do this typically with a vendor assessment as well as a kind of digital transformation roadmap analysis as well. As you can see here, there's a lot of detail that goes into it, and the work is just really centered on a path to value assessment that helps end users make this ROI-informed decision, but there's got to be a lot of detail behind it and a lot of depth. And it comes down to this value creation equation, which really defines the path to value. So on the one side, you have to answer the question that's implicit here on our y-axis, which is, what are the pain points and bottlenecks that lead to cost outlays and missed revenue opportunities? And then, these opportunities are at least theoretically existing no matter how the problem solves. So whether it's with classical computers, with quantum computers, even with non-technical solutions. These aren't quantum computing questions, but questions about, high frequency trading in finance, say, or chem informatics. Now on the x-axis, this is where we determine what hardware and software breakthroughs will be needed to achieve, a level of solution maturity that allows you to solve the problem at a given node. Not all industry problems are going to require, full-scale fault-tolerant computers, right? There may be optimized, shallow circuit NISQ devices that can make progress on, simulating highly correlated systems, for example. And this is just an illustrative approach of materials that I give you. You can see that value accrues as you can simulate materials of increasing complexity with greater exactness. But I share this only to say that you do need the detail and the technical depth to make the kind of decisions that really should be meaningful investments for businesses in potentially disrupted industries. So how to engage with us? Well, one way is, of course, to just read some of the thought leadership that we've put out on the topic. It's an area that we're passionate about, that we've invested a lot in. And it's one way to kind of get, familiarize yourselves with how we think about quantum computing and what work we're doing. And then also I just note that we've got a global team with consultants and project work all over the world. So please get in touch with us and reach out to us at quantum@bcg.com. Thanks.
Thanks a lot, Matt.